Today, inorganic membranes are used in a wide range of industries, including water treatment, food and beverage processing, pharmaceuticals, biotechnology, chemicals, and energy. Yet their modern story began in a closed, strategic, and confidential world. As early as the 1940s, in the United States, inorganic membranes entered one of their first large-scale technological applications through gaseous diffusion. During the Manhattan Project, highly engineered porous metallic barriers were developed to separate uranium isotopes in gaseous form, a process requiring extraordinary precision, huge membrane areas, and long cascades of separation stages. These early developments, driven by strategic needs, pushed the control of porous materials to unprecedented levels. Later, in France, similar expertise was developed and refined for the national nuclear program. In the 1960s and 1970s, French teams created extremely precise mineral barriers, whose pores had to be controlled with microscopic accuracy. This research was strategic, sensitive, and limited to only a few experts. But behind closed doors, an exceptional know-how was born. In Montpellier, one researcher understood that this unique expertise could serve far more than strategic industry. Professor Louis Cot became one of the early pioneers of ceramic membranes, exploring how mineral materials could transform industrial separations, resource recovery, and sustainable production. At the same time, in the Netherlands, Professor A.J. Burggraaf and his team at the University of Twente were also developing major contributions to ceramic and inorganic membrane science. These pioneering efforts, carried out in parallel, helped move inorganic membranes from a strategic and confidential field toward an open scientific discipline. Around them, a new scientific culture began to emerge, connecting chemistry, materials science, engineering, and industrial needs. What had been developed for some of the most demanding separations in the world could now become a source of innovation for society. In 1989, Professor Louis Cot co-founded, with Jean Charpin, the first international conference on inorganic membranes, ICIM. More than 300 participants from 26 countries gathered in Montpellier. Before the age of the internet, the world came here to discuss a science that was still emerging. Researchers from France, Japan, the United States, the Netherlands, Germany, and many other countries shared methods, materials, and visions for the future. What had once belonged to confidential laboratories became an international scientific discipline. In the following years, the field became increasingly structured. In 1991, Ramesh R, Bhave, a member of the ICIM Scientific Committee, published Inorganic Membranes, Synthesis, Characteristics, and Applications, one of the first books devoted to inorganic membrane separations and applications. This work helped gather and disseminate knowledge on materials, properties, processes, and applications at a time when the field was rapidly emerging. A few years later, in 1996, Professor Louis Cot and Professor A.J. Burggraaf edited another major reference book dedicated to the field. Together, these milestones helped transmit knowledge to a growing international community and gave visibility to a new generation of researchers. From Montpellier, Twente, and other pioneering laboratories, the field continued to expand through an increasingly international scientific community. Researchers and laboratories across Europe, the United States, Russia, Japan, and more recently China contributed to the development of new materials, processes, and applications. What began within highly specialized laboratories had become a global research and innovation community. Technologies first designed for extremely demanding separations soon found broader applications. Inorganic membranes are now used in water and wastewater treatment, gas separation, solvent dehydration, purification of complex process streams, and integrated membrane reactor systems. Their resistance to temperature, solvents, pressure, and harsh chemical environments opened opportunities that conventional membranes could not always reach. Today, new generations of researchers and engineers continue to build on this legacy, advancing membrane science and technology worldwide. In 2026, ICIM returns to Montpellier, where yesterday's secrets became tomorrow's solutions.